We've got a little bit of a contrast occurring in our modern populations when we start to look at our strength and our physical ability, and particularly when we contrast that against our ancestors and people from non-industrialised countries. You can kind of see that we have a level of strength that perhaps is not appreciated very well in a Western society. When you start to see some of the survey figures come out looking at the strength and physical ability of our youth, it makes for fairly miserable reading overall. Every so often you'll see a report come through where they've looked at 10-year-olds and sort of measured their physical strength, their ability to climb, their ability to hang off a bar, those sorts of things. And every single time those surveys come out, they are a little bit worse than the previous survey. And indeed, you see some of these reports where some of the assessments that they try and put these youth through, they just flatly refuse to do them. They flatly refuse to hang from a bar because it is never something that they have done before. Now you contrast that to anyone over a certain age, and probably anyone over about age 40, where you are climbing trees and climbing roofs and jumping off and breaking limbs all the time. The ability to kind of hang off something was neither here nor there. It was sort of something you did probably most days. This is just sort of recent numbers, just put a bit of an American spin on it. The previous one was from the UK. So just showing the deterioration in the fitness of our youth, and particularly when you look at the fitness and strength of females. And you'll see, just by virtue of the slides you got here, I've got this sort of presentation very heavily biased towards women, because they are affected disproportionately by some of the factors that I'm going to go through and discuss. So you can sort of see the number up there, 42%. It actually drops down to something like 30% with female youth. And it's no surprise when we look at the factors that we're exposed to in our modern Western world. What are the role models we have? What's the environment that we're in? Well, you look at the types of role models for women in particular. Strength's very unfashionable. If anyone wants to push my buttons after this presentation, ask me about trying to buy a pair of jeans if you've got any leg muscles these days. It just doesn't work. We live in environments where strength is very much optional for us. It's bad enough where I come from in New Zealand, but as soon as you kind of hit the mainland US, coming through the airports, and we see the number of travelators and escalators and everything else, it allows you to opt out of your own physical movement. You can contract your movement out to various devices, various labour-saving devices, and we're paying a fairly heavy price for that. We were waylaid at San Francisco Airport for about 5 hours when we first came in on Saturday, and we spent most of that 5 hours watching people refusing to move, people jumping on the travelators and just opting out of their movement. We're in a very sort of pharmaceutical-rich environment and probably a very unappreciated fact behind many of those pharmaceuticals is that they do have an impact on our muscle quality, they do have an impact on our strength either directly or indirectly. And it's probably fairly well appreciated that the class of drugs that fall under the label of statins, they do have a fairly direct impact on our muscle strength. So as we were becoming more and more reliant on pharmaceuticals to prop our health up, it is having an impact on our muscle quality and our muscle strength overall. Add all the factors up in our Western society, and by the time that all of us in this room become dottery little old men and little old ladies, this is what our strength gets reduced to. Sitting in a chair with a little stretchy band above our head, trying to maintain the last slither of strength that we have, the last piece of functionality that we might have, so that we can maybe pick up a cup of tea without spilling it on ourselves. Good luck with anything beyond that. Whilst we've got this backdrop of an environment of basically lack of movement, lack of physical activity and the effect on our strength, we are more fat obsessed than we have ever been. We're not particularly worried about our strength, and I'm probably preaching to a slightly different audience from kind of what's out in the wider society, but we are fat obsessed. We obsess about high-fat diets, and probably some of these factors do pertain to this particular group. We obsess about high-fat diets. We obsess about low-fat diets. We obsess about how we got fat. Many of the lectures that are taking place within this conference are about how we became obese, what happened, what was the critical factors. We're obsessing about how we get unfat. Very, very rarely, with the exception of kind of a few sort of key speakers, and you're sort of seeing probably a core group of them today, and certainly Keith Norris's talk yesterday. Very rarely do we obsess about strength and muscle mass and muscle quality. Certainly not as our primary focus. It's kind of down the way a little bit after we've tackled the fat issue. We've become very binary in terms of how we view our bodies. We view ourselves as either fat or not fat. Now, this is both the general public, and I'd hate to say it, clinicians fall into this as well. Unfortunately, many doctors will look at their patients, many trainers, many nutritionists, dietitians, they will look at their patients, and they will view them as either fat or unfat, or not fat. Very, very binary. If you are not fat, you are deemed, by and large, healthy, certainly compared to those who are overtly obese in our modern society. And I feel that we need to get past this sort of very binary thinking, particularly when we take into account that our skeletal muscle mass is the largest tissue mass on our body, and becoming more and more appreciated that muscle mass is an endocrine organ in and of itself. It's not just this mechanical entity that shifts your joints around and allows you to move through the environment that we are in. It is actually regulating the rest of our body via some of the signals that muscle mass sends out as part of that contractile process. When we go through some of those key functions outside of just sheer mechanical movement, we can kind of see where some of those signals are coming from. Stefan Guillenet touched briefly yesterday within his leptin talk on interleukin-6 and the signal that sends to help regulate metabolism. We've got muscle mass helps regulate our immune function. If you ever have the misfortune of ending up in hospital suffering a very serious illness or trauma, you better hope like hell you're in there with a large degree of muscle mass, because it will swing the odds in your favour. There is a little bit of early research out there looking at some of the signals being sent out from contractile muscle with regard to anti-tumour effects. And of course we have the effect of muscle mass on itself and on our bone density. So the muscle mass becomes highly regulatory of itself. Contracting muscle leads to more contracting muscle. Contracting muscle increases your bone density. And it's not just a mechanical thing, it's coming from these compounds, these things we call myokines. So in effect, these compounds are sort of functioning like hormones within our body, giving muscle mass an endocrine function overall. Knowing this, and when you sort of dive into the literature, there's actually a fairly good level of literature around some of these factors. But when you actually look at it from a public health perspective, we do not focus on muscle mass as a relevant endpoint. The vast majority of our public health measures, our public health recommendations, do not consider your muscle mass, do not consider your strength. They're focused on fat, they're focused on disease. They're not sort of focused on anything to do with your muscle mass, despite the fact that your muscle mass plays a very, very important role in mitigating many of the things that we are trying to deal with at a public health level. So I'm going to park that there, and we're going to focus on a couple of key issues with regard to our muscle mass and our muscle quality overall. The first one, many people will be quite familiar with, and it has been mentioned a few times already within this conference, and that's sarcopenia. Now, sarcopenia is any loss of muscle mass and function. Now, traditionally, it's always been associated with aging. It's been something that little old men and little old ladies suffer from in the later years of their life. But very recently, and I think it's only been in the last sort of 5 or so years, maybe a little bit less, that the aging component has been taken out of that definition. That it isn't something that is restricted to little old men and little old ladies. It is something that can affect you at any part of your lifespan. It's affected by chronic diseases. So many of the metabolic diseases that we face within our society, diabetes, metabolic syndrome, all those sorts of things, have an appreciable effect on our muscle mass. It is impacted by low protein intake and obviously physical inactivity. Alongside that, and probably the lesser known of the two, is a condition called dynapenia. And this is where we look at not the muscle mass by itself, but the actual contractile function of the muscle mass. So the neural aspects, the muscular aspects, how much force can that muscle that you have how much force can it generate, how much power can it generate. Now, dynapenia can occur without any loss of muscle tissue at all. So I'm going to argue that we do have a good number of people within our society who probably look like they have good levels of muscle mass. You would not look at them and say that they are scrawny, that they are sarcopenic by any stretch, but that they are still suffering from this condition of dynapenia, and it's having an impact on them. A little bit of muscle physiology. I'll keep this at a fairly basic level so I can understand it probably more than some of the people in the room. When we look at muscles, they are in effect slave to the nerves that empower them or innervate them. So we kind of sort of, in a very easy sort of sense, we have slow twitch muscles and we have fast twitch muscles. Now it gets a little bit more kind of in depth than that, but that's at its most sort of basic level. And now those slow twitch and fast twitch muscles are there based on what nerve is feeding them. When we start to see some deterioration in our muscle quality, part of it may be to do with the fact that some of these innervating nerves are being affected by multiple factors. So if you go and take out the nerve that sits upstream from a muscle, the muscle downstream from that nerve will suffer an effect from that. So if we have a nerve that is in effect cut from its muscle, the muscle will decline. So very loosely, this is sort of what we're talking about with sarcopenia, that the muscle below the nerve is starting to go into decline. So we see a decrease in the muscle mass overall. You can see it sort of relatively clearly on these scans. So you can see, so as we go through our lifespan here, you've got more and more of these sort of white flecks appearing within the muscle mass. So this is a slice through a thigh muscle. And these are non-contractile elements that are taking the place of where muscle fibers used to be. So it looks on that basis that it is a function of aging. As you kind of go through your lifespan, you lose more and more of your contractile elements out of your muscle. But then you only need to look at a very similar slide like this, where you start looking at athletes and you do not see the same deterioration in contractile elements. So, between a 40-year-old athlete and a 70-year-old athlete here, they both have pretty much exactly the same sort of muscle mass going on, compared to sedentary man, where you can kind of see very, very low levels of contractile elements and very large non-contractile elements, which is mostly adipose tissue within that slide. There is a degree of compensation that can take place if there are any problems with an upstream nerve. So you can see here that if we were to, if something's happened to the fast twitch motor neuron, so the fast twitch neuron that was going and feeding those particular muscle fibers, there is the possibility that our slow twitch motor neurons can branch over and re-innervate some of those fibers as a degree of compensation. The problem that occurs when that happens is that those muscle fibers that used to be fast twitch muscle fibers by virtue of the nerve that fed into them have now taken on the characteristics of slow twitch muscle fibers. So you can imagine that what's going to happen to your muscle mass if it is being re-innervated by slow twitch fibers overall, or certainly your physical ability. So if we kind of look at what are the key elements involved with this, we suspect that dynapenia is probably a little bit more common than sarcopenia, but certainly there's an interplay between the two. There's a bidirectional flow between the two of those. What's driving the dynapenia seems to come from two directions. So we're seeing changes in the nervous system. There's something going on in terms of the neural input to the muscles, but there's also changes within the architecture of the muscle itself. So the actual muscle fibers seem to be deteriorating. As a part of some of these neural changes, we're seeing this sort of de-innervation, re-innervation, which is changing the muscle fiber type. This muscle fiber type, so if you take on slow twitch characteristics, you are losing a lot of your force development, your power development that you would have had from those fast twitch muscle fibers. And some of the key drivers of that you can sort of see down there. So we're seeing hormonal changes, inflammatory factors, protein intake, and reduced mechanical stress. So those are sort of more of the lifestyle factors. I guess the end result for what we're seeing with the general population is this functional limitation initially, but if you push that to its extreme, you're going to see a lot more physical disability as that takes hold. To summarize it, I guess, in a very sort even more simplistic way, you can view your muscles as basically having hare and tortoise type characteristics. And it's good that we've got that, and I think Sir James have basically touched on it in his talk, that we have the ability just to kind of mosey around at a relatively slow pace, and we'll be using largely slow twitch fibers to do it. But when required, we can exert ourselves at a very, very high intensity and exert very high power outputs, and that's largely the result from our fast twitch fibers. Now, whatever is going on in terms of the environmental factors which are affecting our muscle quality, it's the bunny that's getting it. It's the fast twitch fibers that are being disproportionately affected by those environmental factors. So you can imagine what's happening to our general population, our societies, where we are in effect reducing us to nothing more than a bunch of these guys sitting here. And indeed, when you sort of take that out across lifespan, one of the key things that we try to do with an aging population is to try and increase a little bit of strength and a little bit of coordination and a little bit of balance to stop these people toppling over, so that they're not breaking hips and other bones, because that's, when you get to a little old man and a little old lady and you break your hip, you're in trouble. But we're starting to see this kind of decompress from that elderly population down into the general population. So what are the environmental factors? What is driving this? Why are we seeing this all of a sudden compared to our more ancestral populations? Well, when you look at it, there's inflammatory drivers. So there's sort of just general low-grade chronic inflammation that seems to be having an impact. And this is a theme that we're sort of seeing come through over and over again with all of the talks within this conference, that this low-grade inflammation is very detrimental to our health overall across many tissues within our body. There's a nutrition element, obviously. Part of that is obviously protein intake, but maybe that protein intake is also a marker for micronutrient status as well, so there's a part to play there. Obviously, we're inactive. We've got sort of disuse and immobility. Interestingly, Keith Norris touched on yesterday in his talk about the effects of being in microgravity environments up in space, and if we're looking at space exploration, we're going to need to answer a few serious questions before we try it. Having a discussion with Keith afterwards, we're in effect in our modern environments on Earth, we are creating these low gravity environments because we are contracting our movement out to other devices. You guys sitting on a chair, your muscles aren't taking the load of gravity, the chair's doing it for you. All the machines that we use on our behalf, we're not exerting ourselves against gravity, we're asking the machine to do it for us. So in effect, whilst it's not the same sort of compressed time span that we're seeing with astronauts, we're sort of certainly seeing some of the similar effects over a more prolonged time period impact on our muscle mass. And then clearly there are endocrine issues as well. So, vitamin D status, insulin resistance, those sorts of things keep popping up time and time again. Now, all of those factors overlap. They're not distinct factors by any stretch of the imagination. They're all kind of playing off each other. Look at our diet and sort of single that out as one factor, and you look at some of the papers that are out there. The general population is having 70% of their diet, which is fueling this low-grade inflammation. So you can kind of see potentially where there's a big driver just in that alone. When we look at the diversity of body types across the population, we have historically tended to associate sarcopenia with being down sort of more this end of the population. So these are the small frames, the frail frames, the low muscle mass frames. And indeed, that kind of fits with our general idea. So these are people with low to normal BMI, low muscle mass, and as a result, low bone mass. Interestingly, these people are also metabolically unhealthy as well. So whilst they aren't overtly obese, they tend to take on many of the same characteristics that we will often see in those who have poor metabolic health. And you can sort of see some of those factors line up there. Interestingly, and this is what has changed a little bit since I did my training sort of very many years ago, we used to think of the obese as actually having very good muscle mass. We used to think of the obese as having very good bone mass. When you are carrying that amount of weight around, we thought that your muscles have to compensate, your muscles have to get bigger and stronger, your bone density has to go up in order to cope with that muscle mass. But it seems that is not the case. And there's some very early research out there on sarcopenic obesity. So these are people who have a high body mass index, but they still have low muscle mass and low bone density, and have very many of the same factors going on that we see with the sarcopenic. One group of authors described this as a confluence of two epidemics. So we're kind of seeing a very big overlap between the extremes. Indeed, we can't even look at an individual and try and assess whether or not they've got some of these factors going on, because the size, the shape, the body mass of a person really doesn't give us a good, clear indication as to whether or not someone has a good level of muscle mass, a good level of bone mass. Even on the adiposity front, you cannot look at someone and make this binary call that they are either overtly obese or they're not obese and therefore healthy. So some of the information that's out there around visceral adiposity, even at very, very low rates of visceral adiposity, you're seeing sort of deterioration in metabolic health in people who look at an otherwise normal body mass. And even in obese individuals, you're seeing, some of these reports that obese individuals may present with depleted muscle mass and strength similar to emaciated patients, which is it's a little bit different from where things were, or certainly our understanding was a few years ago. At a public health level, we are very, very focused on cardiovascular disease. That's sort of our number one target overall, although sort of probably likes of diabetes is catching up. Now we've got all these sort of factors that are driving into cardiovascular disease, and we're sort of debating, the relevance of these factors and how we treat some of these factors individually. And I guess we have recognised that there is an aspect of muscle health, there is this aspect around sarcopenia, but we see them as two kind of distinct and very sort of clear health aspects that we're trying to tackle. There's no sort of real line between those, but again, when you go into the research, it gets very interesting. That line is quite clear when you look at these sorts of things, that some of the factors that we are looking at down through this side are actually being initiated over here. That maybe it's something to do with our muscle function, the metabolic function of our muscle mass, which is playing a direct role in initiating this cascade down through this side. So we need to build that bridge between the two. And indeed, and this is sort of some of the diagrams that I've stolen out of the literature, when we look at sort of the triad between our muscle mass, our bone density, and our adipose tissue as sort of three key factors that we're looking at, it seems to be, based on the literature that I've gone through, it seems to be initiating over this side, that there are changes within our muscle mass as a result of some of those environmental factors, and it's starting to drive this sort of loop up through here. So the changes in our muscle mass are leading to changes in our adipose tissue, leading to changes in our bone mineral density. And you can kind of see where those arrows go. It's a sort of a nice, neat little circle that's just going to keep going round and around. One of the things that sort of comes through pretty clear when you look at muscle mass from an endocrine standpoint, when you look at the compounds being released out of muscles, and focusing on specific myokines, is that when we are trying to address some of the issues that we are concerned about, the type 2 diabetes, the cardiovascular disease, the cancer, in actual fact, the myokines being released from our muscle mass deal directly with those issues. That some of those myokines are tackling the issues that we're trying to tackle sort of head on through muscle contraction. Similarly with some of the adipokines coming out of these visceral adipocytes, is that the myokines, the muscle that are released from muscle contraction, are blunting those adipocytes, the effect of those adipocytes overall. So again, as much as we're kind of focused on this sort of stuff up here, we're sort of focused very, very heavily on our fat mass, we perhaps need to shift the focus back over here due to what we're starting to understand around these myokines and the effect that they're having. I'm going to return to this point here. Whilst we are sort of developing this understanding of those myokines and the effect that they can have on our metabolic health and some of the other disease markers that we're concerned with, we still have no dietary recommendations that elevate muscle mass and muscle strength up to a functional relevant endpoint, which is a bit of a travesty. And indeed, when we look at the general public health memes that we have out there, particularly with regard to cardiovascular disease, we're telling people to prevent cardiovascular disease later on in their life, so largely past sort of age about 65. by reducing their saturated fat intake now. Now, the subtext to that is that, hey, if that ends up sort of making you a little bit scrawny or weakening your body, we'll deal with that later. It's not really relevant at this point in time. Your functional health, your physical ability right here, right now, is not a relevant endpoint to the minds of those sort of dealing with some of these public health messages. And I think that's a wrong approach. And indeed, when we look at our commonly held public health messages that we have out there, we're telling people to eat grains and vegetable oils. Well, we've got good information to suggest that they are part of an inflammatory diet. We're telling people to go on low-fat diets, which is going to have an impact on our protein intake. And we're telling people to stay out of the sun, having an impact on vitamin D. And in the meantime, this is kind of the type of exercise that we're telling people to do. Oh, well, if you need to build up your physical fitness, go and engage in some sort of endurance-style training first and foremost. We still haven't elevated strength training up to where it probably needs to be. When we just focus on the protein side of it, because of the fear that has been generated around saturated fat intake, it has put a large portion of the population off of eating meat, any type of meat, because of the association between animal proteins and the inherent amounts of saturated fat contained within those animal proteins. So whilst probably at a population level, just tracking straight protein, it seems that protein's probably fairly kind of static. I think that we've actually probably swapped a lot of meat proteins out and put a lot of non-meat proteins back in to replace it. So the protein quality's probably fallen. There is an argument to suggest that, hey, protein's protein, it doesn't really matter where it comes from once it's in your body, but again, if we dive into the literature, it doesn't particularly support that, and we can see distinct differences in muscle mass, muscle quality, muscle strength in women who are consuming animal protein all the way through there. When we focus on our obese populations, we can see that muscle strength is a bigger factor as far as their overall mortality is concerned, rather than the actual amount of fat mass that they are carrying. So again, if we kind of add all those things up, if protein improves our strength and our muscle quality, and it's our muscle strength and quality that is determining our overall mortality, we need to kind of connect those dots and elevate that as far as the public health messages go. So when you take the research in totality, the elephant in the room amongst all of this is that if we are going to elevate our muscle function, our muscle quality up to where it needs to be, we have to change the dietary guidelines. That's all there is to it. The current dietary guidelines do not support what is sitting in the research as far as that muscle strength and function goes. It has to be reconsidered. So I'm going to leave you with a hope that we can move away from this very sort of binary thinking around whether we are fat, whether we are not fat, and whether that determines our health. And I hope that we can convince people to start looking at the population and ask the question, is this person strong or is this person not strong? Because I think that's probably the more relevant question overall. And if we are going to be worried or concerned about our fat mass, we need to bear in mind that the skeletal muscle is the organ that counteracts body fat. So I will leave it there. Thank you. Any questions? Yeah.
Hi, Jamie. Is it on? Testing? Can you hear it? Oh, there it goes. So thanks for coming all the way from New Zealand to share this stuff.
It's not that far.
I'm coming at this from the approach of shoes are not paleo. And I was noticing one of the things you talked about, the big contributor to sarcopenia and dyspnea is nervous system impairment. And so one of the third greatest sensory concentration area in the body, aside from the face and hands, is the feet. And I was... which is also the most directly relevant to all types of locomotor activity. So I was wondering if, especially in New Zealand, I know there are more populations of people who don't wear shoes. I wonder if there's any any attempt to look at the difference in muscle development among populations that wear shoes and that don't.
Given the temperature back home at the moment, there are plenty of people wearing shoes. So there's not that level of research back home. And I think New Zealand, don't over-romanticise New Zealand. New Zealand has pretty much the same sort of issues that America faces overall. We have populations who are wearing big chunky shoes, high heels all day, and I think gone are the days where the average Kiwi kid spent their entire summer running around in bare feet. So there's not a lot of research taking place back home in that field, and people just aren't hanging out in bare feet anywhere near like they used to. So, but I definitely agree that it's a relevant aspect. That sort of sensory load, that ability to keep adjusting to the terrain underneath you, is actually going to look after some of the neural aspects that I've kind of briefly touched on there. So,
Thanks.
thank you.
Could you say a little bit more about the remodeling of fast twitch, slow twitch fibers? You implied, I think, that we are moving toward more slow twitch as fast twitch gets replaced. But then you also said that remodeled slow twitch fibers do not function as well. So what I'm wondering is, to what extent is that process of replacing fast twitch with slow twitch, to what extent is that process reversible, or what do we know about that?
Unfortunately, and that was one of the key things I was looking for in the research, because they were very sort of clear that there is, in some cases, this compensation that will take place when you lose fast twitch input into the fibers, is that slow twitch branch can move over and try and kind of maintain or save that muscle mass. There was nothing in there to say that is reversible. Now, I'll stick my neck out and suggest that it probably is to a degree, that the muscle fibers themselves are generally sort of fairly plastic. They're not heavily distinct in one type or the other. So you can take a slow twitch fiber and strengthen it up and speed it up to a point that it can take on some of the characteristics of faster fibers. It won't still be that very high speed, high velocity, high power fiber overall, but it can kind of come up to a level which may give people enough compensation in their daily life. There was nothing that I saw, unfortunately, that suggested that once you have lost that fast twitch neuron input into that fiber, that you can then regrow it back in. So there's a big hole there as far as the research goes. Yeah. Mr. Norris.
That was my question exactly. If we do lose the innervation to fast twitch fibers, are there any studies that say that innervation can be replaced? Not necessarily remodeling, but actually, re-innervation of a lost.
I haven't seen anything, so that's, yeah.
So you quoted an interesting study with the vegetarians and omnivores with the same protein intake, and said their muscle mass was lower. But I was wondering if you think that could be more due to things like creatine and omega-3s and other things that vegetarians tend to be deficient in?
Absolutely, and I sort of briefly touched on that at the start when we were sort of discussing protein intake overall. So we can look at protein intake, and particularly animal protein intake, and we shouldn't get caught up in the fact that it is just the protein aspect of those foods that we're eating that are having an effect on our muscle quality, and it may be more the micronutrient status or part and parcel of that. So things like your creatines, some of the minerals that are sitting in there that help maintain our muscle mass. So yeah, there will be that difference there, I think.
Cool. Thank you.
First, thank you. Great presentation.
Thank you.
Very engaging. Have you come across what the best way to refuel the muscles after explosive fast twitch usage where you deplete glycogen, what that might be?
Well, that's where your carbohydrate intake's going to come in, and those fast twitch explosive fibers are using that as their predominant fuel. You're not going to get very high levels of power out of those muscle fibers using anything else. So then you're applying the ancestral type diet and look at those sort of carbohydrate sources, so our starches, our fruits, those sorts of things. So it's not going to take anywhere near the amount that we probably traditionally have tried to pump back into endurance athletes. There's a very kind of there's a very good kind of level of recycling of some of those fuels within those sort of fast twitch high output muscle fibers, but just a good level of starch in the background. Cellular starches, that'll be the way to go.
Okay, in a particular window, particular type of starches?
In that sort of immediate post-exercise window, I'm a little bit kind of mixed on the pre-fueling side of things. I don't think we necessarily need to pre-fuel our muscles, providing our background diet's all right. But certainly if you are looking at repeating your explosive efforts within a short window, you'll probably want to refuel them straight away. But then you take the likes of James Steele's talk, where he's sort of suggesting that the intensity is really key and you don't need to do kind of lots of high frequency, high intensity efforts. Well, if you're only doing very infrequent high intensity efforts and you've got sort of 3-4 days in between those bouts, that's plenty of time to reload. So maybe that post-workout window becomes less critical overall, but maybe still critical for those who are athletes and have to re-engage themselves in a very short period of time. So.
Cool, thank you.
So it's possible to maintain muscle mass as we grow older. It may not be possible to reinnervate motor neurons, but for athletes, what is the best way, do you think, to prevent degradation of fast-twitch motor neurons and kind of maintain rate firing?
Move with high velocity and under high load. So that's one of the things that I get a little bit concerned about as far as the maintenance of these sorts of things, is that we still have a predisposition towards doing endurance type exercise. Now, when I say endurance type exercise, that's cycling, running, swimming, all of those sorts of things. But as soon as you start getting into more, the prolonged metabolic type workouts, the 20-minute plus workouts, that is in effect endurance exercise still. Once you are measuring yourself past 30 seconds, I guess, in terms of your muscle contractility, you are starting to get into the realm of endurance exercise. So I think as far as maintaining those high output, fast twitch fibers, it is the very short burst, high velocity, high power loads that we're looking at. And again, to go back to Keith Norris's talk yesterday, where he touched on eccentric loading for those who are in microgravity environments, we need the same thing. We need to put ourselves under eccentric loads. Well, good luck putting yourself under an eccentric load and combining endurance exercise at the same time, because you will not walk for weeks if you do that. It's just an impossibility. You'll do a hell of a lot of damage to your muscle mass. So it is those very short burst, high intensity activities that we need to maintain those fast twitch fibers.
So it appears that the fast twitch definitely goes to slow twitch over time, but you can keep your muscle mass with slow twitch. What is the disadvantage of having a lot more slow twitch if you're not performing athletically? Like into old age, what do you lose with only slow twitch as opposed to both? Good
question. So if let's say you're walking down the footpath and you catch, sidewalk. You catch a lip on the concrete and you start to stumble. It is your fast twitch fibers that grab you, hold your balance, and pull you back, because it is happening at such speed, and it's your body weight is starting to lose its balance and starting to gain momentum. Your fast twitch fibers may not be fast enough and strong enough to grab your mass to pull it back and rebalance it. So if you've lost a lot of your fast twitch fibers and you are basically a big bundle of slow twitch muscle, it increases the risk that if you do lose balance, if you do go into a fall, you are not going to pull yourself back, and you are going to land on your hip and you're going to break your hip, and you are in trouble. There seems to be kind of this, I guess, feeling amongst the general population that, if you break your hip, you're in hospital for a little bit and there's a little bit of rehabilitation that goes with it. Well, if you break your hip, I think it's something like 1/3 of the people survive that. 1/3 of them will be dead within a very short period of time. And the remaining third will be basically invalids for the rest of their remaining life. So it becomes very, very important as we age that we maintain that function to protect ourselves. We're going to suffer illness, we're going to suffer viral loads, all those sorts of things. And it seems that the more muscle mass we have, and in particular that fast twitch muscle mass because of the downstream myokines that come from that muscle mass, that is what's protecting us when we do go through those periods of illness.
Great. And follow-up question, are there any tools available to the consumer to be able to check the type of muscle fiber they have in different parts of their body?
Not that you'll be able to use yourself. It's basically muscle biopsy to do that.
Just biopsy,
Big fat needles.
which is
Yeah.
painful, right?
Yeah.
So, is there a way to train fast-twitch muscle fibers without high-intensity exercises,
Without high intensity?
especially for people who have physical disabilities?
Again, it's sort of more, I guess it's going to depend on how you frame high intensity exercise. So if you're looking at, like a CrossFit type model, is that what we need to get everyone to do? Do we need to push them through to that type of thing? No. But if you can progressively increase someone's load, progressively add in more and more eccentric type exercises, change their speed of movement. So we're talking about their speed of movement, loads that are suitable for them, not what would apply to athletes. And do that in a very progressive type manner over a long period of time. It's not a short turnaround by any stretch of the imagination. Get all those other factors right, all those other environmental factors. So it's not just the exercise side of it, it's the sunlight exposure, it's maintaining low levels of stress overall, good diet. All of those factors come into play with your muscle mass and muscle quality. Then you will get an appreciable increase in people's fast twitch muscle fibers.
Also, I was going to ask, what are some examples of eccentric exercises?
Doing a squat, as you're lowering yourself down, working against gravity, trying to resist that load of gravity. That's eccentric loading. So the muscles are basically under load, but kind of controlling that lengthening process while they're under load. Yeah.
Hi there. Would there be a particular danger to young people involved in excessive endurance training, given that window of development of all their nervous system and that?
Yeah, I think so. I've had a little bit of time working with elite track cyclists, and it gets very interesting when you see people who are bought into that sport, having grown up as kids, where they just kind of ran around and maybe they owned a BMX, and if anyone knows anything about BMX riding, it's all kind of stop-start sprint type stuff. When you bring them into the sort of sport of track cycling later on, you can see the power and velocity that they have. Now, the contrast to that is, as we've kind of come into this world of endurance type athletics, is that I've seen far too many 7, 8, 9-year-old, 10-year-old children who have been given a mini-me road bike and a Lance Armstrong kit by their father, and they get taken out for 50, 60, 70 kilometre bike rides day in, day out. And then you see them come into a sport which requires more high velocity, high power output from them. They are literally tortoises out there. They're very, very slow. They've got one speed and one speed only. So it almost sort of seems that by engaging young children in endurance type endeavours too early, is that you train their fast twitch fibers out of them. They seem to be being exposed to this chronic cardio load. And again, look at the food environment that they're in, the school environment, the sunlight exposure environment. They have all of the factors there for a deterioration of their fast twitch muscle quality right from the get-go. And you can kind of see it as they start to come into those athletic endeavours later on that might require a bit of power out of them.
And just looking on the other side of the coin there, are there particular dangers if you want to do load-bearing exercises with young people?
Not in an acute sense, but all the same rules apply, is that you can overtrain anyone using any variable whatsoever. So if the loading's too high, if the frequency's too high, if the intensity's too high for that particular person, you can overdo them. So the same rules apply. But again, you kind of look at some of the information that's already been presented this morning. The intensity is the key rather than the frequency. So you can chuck kids into high intensity, high load exercise, but just give them plenty of time to recover and make sure they're doing their sleep and their nutrition and everything else well.
Let's give Jamie a big hand.
Thank you. Very binary in terms of how we view our bodies. We view ourselves as either fat or not fat. Now, this is both the general public, and I'd hate to say it, clinicians fall into this as well. Unfortunately, many doctors will look at their patients, many trainers, many nutritionists, dietitians, they will look at their patients, and they will view them as either fat or unfat, or not fat. Very, very binary. If you are not fat, you are deemed, by and large, healthy, certainly compared to those who are overtly obese in our modern society. And I feel that we need to get past this sort of the very binary thinking, particularly when we take into account that our skeletal muscle mass is the largest tissue mass on our body, and becoming more and more appreciated that muscle mass is an endocrine organ in and of itself. It's not just this mechanical entity that shifts your joints around and allows you to move through the environment that we are in. It is actually regulating the rest of our body via some of the signals that muscle mass sends out as part of that contractile process. When we go through some of those key functions outside of just sheer mechanical movement, we can kind of see where some of those signals are coming from. Stefan Guillenet touched briefly yesterday within his leptin talk on interleukin-6 and the signal that sends to help regulate metabolism. Maintain the last slither of strength that we have, the last piece of functionality that we might have, so that we can maybe pick up a cup of tea without spilling it on ourselves. Good luck with anything beyond that. Whilst we've got this backdrop of an environment of basically lack of movement, lack of physical activity and the effect on our strength, we are more fat obsessed than we have ever been. We're not particularly worried about our strength, and I'm probably preaching to a slightly different audience from kind of what's out in the wider society, but we are fat obsessed. We obsess about high fat diets, and you know, probably some of these factors do pertain to this particular group. We obsess about high fat diets, we obsess about low fat diets, we obsess about how we got fat. Many of the lectures that are taking place within this conference are about how we became obese, what happened, you know, what was the critical factors. We're obsessing about how we get unfat. Very, very rarely, with the exception of kind of a few sort of key speakers, and you're sort of seeing probably a core group of them today, and certainly Keith Norris's talk yesterday. Very rarely do we obsess about strength and muscle mass and muscle quality. Certainly not as our primary focus. It's kind of down the way a little bit after we've tackled the fat issue. We've become very we've got a little bit of a contrast occurring in our modern populations when we start to look at our strength and our physical ability, and particularly when we contrast that against our ancestors and people from non-industrialized countries. You can kind of see that we have a level of strength that perhaps is not appreciated very well in a Western society. When you start to see some of the survey figures come out looking at the strength and physical ability of our youth, it makes for fairly miserable reading overall. Every so often you'll see a report come through where they've looked at 10-year-olds and sort of measured their physical strength, their ability to climb, their ability to hang off a bar, those sorts of things. And every single time those surveys come out, they are a little bit worse than the previous survey. And indeed, you see some of these reports where some of the assessments that they try and put these youth through, they just flatly refuse to do them. They flatly refuse to hang from a bar because it is never something that they have done before. Now you contrast that to anyone over a certain age, and you know, probably anyone over about age 40, where you are climbing trees and climbing roofs and jumping off and breaking limbs all the time. The ability to kind of hang off something was neither here nor there. It was sort of something you did probably most days. This is just sort of recent numbers, just put a bit of an American spin on it. The previous one was from the UK. So just showing the deterioration in the fitness of our youth, and particularly when you look at the fitness and strength of females. And you'll see, just by virtue of the slides you got here, I've got this sort of presentation very heavily biased towards women, because they are affected disproportionately by some of the factors that I'm going to go through and discuss. So you can sort of see the number up there, 42%. It actually drops down to something like 30% with female youth. And it's no surprise when we look at the factors that we're exposed to in our modern Western world. What are the role models we have? What's the environment that we're in? Well, you know, you look at the types of role models for women in particular. Strength's very unfashionable. If anyone wants to push my buttons after this presentation, ask me about trying to buy a pair of jeans if you've got any leg muscles these days. It just doesn't work. We live in environments where strength is very much optional for us. It's bad enough where I come from in New Zealand, but as soon as you kind of hit the mainland US, coming through the airports, and we see the number of travelators and escalators and everything else, it allows you to opt out of your own physical movement. You can contract your movement out to various devices, various labor-saving devices, and we're paying a fairly heavy price for that. We were waylaid at San Francisco Airport for about 5 hours when we first came in on Saturday, and we spent most of that 5 hours watching people refusing to move, people jumping on the travelators and just opting out of their movement. We're in a very sort of pharmaceutical-rich environment with, and probably a very unappreciated fact behind many of those pharmaceuticals is that they do have an impact on our muscle quality, they do have an impact on our strength either directly or indirectly. And it's probably fairly well appreciated that the class of drugs that fall under the label of statins, they do have a fairly direct impact on our muscle strength. So as we were becoming more and more reliant on pharmaceuticals to prop our health up, it is having an impact on our muscle quality and our muscle strength overall. Add all the factors up in our Western society, and by the time that all of us in this room become dottery little old men and little old ladies, this is what our strength gets reduced to. Sitting in a chair with a little stretchy band above our head, trying to maintain